This is question 12 from the third CSAT Sample Paper. In this question we're told we take out a loan of size L, so this is measured in pounds or some other currency. We're told the annual interest rate is R, but we're actually charged interest every month. We want to repay an amount P every month, and we want to have completely paid off what we owe after M months. And we're asked to find the value of P that we need to repay every month to make this true. Okay, so if you want to have a go at this question yourself, pause the video now. Well, I think the first thing we have to do is, we were told the annual interest rate, but everything else is happening monthly, so it's probably easiest to work out the monthly interest rate and work from there. So let's do that. Well, if we're trying to find this monthly interest rate, what can we do? What we can do is think, if we applied this 12 times with compound interest, we'd have the same as if we applied the annual interest rate once. And then we can use that fact to find K in terms of R. So imagine at the start we're not paying them money back each month. So it's just money, it's just a loan sitting there not being paid back, accumulating interest. Because that's sort of the basic case when we're just looking to find the interest rate at this point. We're not actually calculating P. So we'll just deal with a simple loan. Then suppose n months have passed. How much do we owe? Well, we start with the loan L, and after 1 month, the amount we owe is multiplied by 1 plus K. That's what interest rate means. So it's like we have one lot, the initial amount, plus K times the initial amount. And then we apply this factor 1 plus K every month. So after n months, we owe L times 1 plus K to the n. This is just standard compound interest. So one thing I'm noting here is it says we're charged interest. I'm taking that to mean same as it's added to the debt, the amount we owe. So now what happens after 12 months or 1 year? Well, that's just n equals 12. So we owe L times 1 plus K to the 12. And that's the same as if we applied interest rate R once. So that means L times 1 plus K to the 12 equals L times 1 plus R. And now we can cancel the L's. And if we want to find K in terms of R, we can just take the 12th root of both sides and subtract 1. So we get K is 1 plus R to the 12th minus 1. So you can anticipate from this that the values we're going to get in our final answer aren't necessarily going to be very simple, because they're going to have 12th roots and so on everywhere. Okay, so now let's think what happens if we're repaying the money, as we're told in the question. So we'll look at the months from the start, which is when 0 months have passed, to when m months have passed, which is when we want to finish. And we'll look at the amount we owe at each step. So we start off owing an amount L, which is just the amount we borrowed. And then how does that change after 1 month passes? Well, it's multiplied by 1 plus K because that's the interest, but we subtract P because we pay that back. So this goes to L times 1 minus K minus P. It's worth noting the order of operations here. So I've interpreted it as they apply interest and then you repay at the end of the month. You could do this the other way around. So you do L minus P and then multiply the whole thing by 1 plus K. So if you did that, you get a slightly different answer to what I'm going to get at the end. The process we're going to do, the steps we're going to do would be very similar all the way through. So I'm not going to do both ways. I'm just going to use this assumption as to the order we do these things in. I think in the CSAT, it doesn't particularly... This is the kind of thing that doesn't particularly matter, because they're going to read what you've done and they can reward you if you've interpreted the question one way or the other, as long as your working is correct. So now what happens is we go to the next month, the second month. Well, if we apply these operations again, we multiply this whole thing by 1 plus K and then subtract P. So this term we're going to have an extra factor of 1 plus K, and then we're going to have P times, this minus P also has to be multiplied by 1 plus K, and then we take away an extra minus P at the end. So one way of thinking about this term is this is the amount of interest you would have paid, the amount of extra interest you would have paid if you hadn't paid off P the previous month. And then we just repeat this step every month. So by the third month, we've added an extra factor here. And then this whole part is multiplied by 1 plus k. So we have a 1 plus k squared from here and a 1 plus k from here. And then we subtract an extra p at the end. So you can see what's going to happen is each month, this part, we just increase the power by 1. And here we're going to increase the power in each term by 1 and add an extra term of 1 at the end that we're taking away. So what we're getting after m months is this is going to be to the power m. And here we're doing minus p times, where we have a 1 from the final amount we paid off, times 1 plus, we're going to have 1 plus k from the previous month and then 1 plus k squared from 2 months before, all the way up to 1 plus k to the m minus 1, because notice the highest power here is 1 less than the number of months that has passed. So that's an expression for the amount after m months. We're eventually going to set that equal to 0 because we want to have paid it off after m months. First, let's simplify this. So this here, this part we've multiplied p by is a geometric series with common ratio 1 plus k. So that means the sum of the first m minus 1 terms is 1 plus k to the m minus 1, all over 1 plus k minus 1, and the bottom just simplifies to k. So that means that the amount we owe after m months is just this, but with this substituted in, like so. And this is what we're going to set equal to 0 because we want to have paid it off exactly after m months. So this is our expression we're setting equal to 0, and we were told to find p. So we just want to rearrange this for p, but that's fine. We can just bring this term over to the right and then divide by this. So that's the same as, if we're dividing by this, that's the same as multiplying by k and dividing by this on the bottom. So we get L times 1 plus k to the m times k divided by 1 plus k to the m minus 1. But remember, k is something we found, it's the monthly interest rate, and we were actually given the annual interest rate r. So here are our expressions relating k and r. 1 plus k to the 12 is 1 plus r, so wherever I have 1 plus k, I can replace it by 1 plus r to the 12th. And k, we found an expression for, it's 1 plus r to the 12th minus 1. So if I now put in r, this becomes 1 plus r to the m 12ths. This, which was k, becomes 1 plus r to the 12th minus 1. And on the bottom we have 1 plus r to the m 12ths minus 1. And that's our final answer, but it's not a nice looking expression, and it's hard to simplify. So we might wonder, could we have made a mistake? How can we check when this is so it's so hard to analyse the behaviour of this? So we can do some tests to check if it's the right kind of thing to be the right answer. So one thing we can do is, let's think about what happens after 1 month. So suppose we want to pay everything off after 1 month. If we stick m equals 1 into this, then this term here, this bracket, and this on the bottom are the same because m is 1. And so they cancel, and we just have L times 1 plus r to the 12th, which is the same as L times 1 plus k. And remember, we said L times 1 plus k is the amount we owe after 1 month, because it's initial loan multiplied by the 1 plus the monthly interest rate. And that's correct, because if we want to pay it off after 1 month, then we need to pay exactly the amount we owe after 1 month. So it passes that test. Some other ways to think about this kind of thing are what happens as different variables go to extremes. So I think it's easier to look at this one than at this one because just because it's slightly simpler and we can easily convert between them. So imagine we make m very big, so I've written that as send m to infinity. Then basically this term, 1 plus k to the m, and 1 plus k to the m minus 1, the ratio of them tends to 1, and that means p tends to just L times k, which is on the top. Does that make sense? Well, that means the amount we're paying back is basically just the interest we accrued on the initial loan. And that's something people do. You just pay off the interest each month if you don't care about paying off the amount you initially borrowed. And if we're sending m to a large number, that means that we don't care about paying off the initial amount we borrowed very quickly. Or if we send this to infinity, we basically don't care about paying off the initial loan L at all. We're just paying off the interest each month. And that means each month we pay off the interest LK, the amount we owe goes back to L, and then we earn more interest LK, we pay it off the next month. And so everything stays the same, so we never pay off the initial loan, but we also don't owe any more. So this is correct, we're just paying off the interest each month. And then another thing we could do is, suppose we make the interest rate very small, and then actually if you did a binomial expression on the bottom, this would tend to m times k, and cancel this to be over m. This tends to 1. So you get the limit being L over m. And that makes sense because if the interest rate is very small, we're basically just paying off the initial loan. The interest doesn't make a difference. And if we want to pay it off after m months, we just split the loan into m chunks. We pay off L over m every month for m months, and then we've paid the whole thing off. So that's also correct. So it looks like this or this is indeed the correct expression.